Hi, everybody. Welcome to Screencast number 3 of Unit 9A, which is our last unit before the AP exam. Some people have been saying they want to cancel the AP exam. If you want to, you can contact your guidance counselor. The AP exam this year is going to be 2 free response questions. We're going to go over a lot of stuff for the AP exam after this unit. The lab that you guys were supposed to have, my computer screen crapped out, so I had to go into school today to get a new computer, get this one swapped out. So that lab will be forthcoming, and also we're going to do a bit about air pollution with what's going on right now with COVID. I don't know if I said this stuff before. I kind of feel like I'm a broken record lately. So this is the third out of 4 screencasts for this. Okay, so your study guide questions are going to start out with a little bit of a review of the nose clip. I put a fun little image in there for you to see as well. So smog is a secondary air pollutant. So you have 2 primary air pollutants coming together under the influence of sunlight. And what happens is the sunlight breaks the UV light breaks those bonds. And what you get is you get a recombination of then compounds. Okay, so you have industrial smog and you have photochemical smog. Your industrial smog is going to be in more industrial areas, and your photochemical smog is definitely going to be under the influence of sunlight. So you're going to have that in more sunny areas. Like your photochemical smog, think about like LA and Athens and Rome, whereas your industrial, you think of like Jersey City kind of stuff, Carney. So industrial smog is coal and oil burning. You have particulates, carbon, sulfur oxides, and carbon oxides. A lot of it is from unburned carbon. So you have sulfur, oxygen, it becomes sulfur dioxide, and that sulfur dioxide comes in with more oxygen and you get sulfur trioxide. Then you come in with water, and that's where you get the sulfuric acid. Okay. Then you add the NH3 and you get this solid brown ammonium sulfate stuff. Okay. Industrial smog is a lot of times also called brown smog. Okay. It's a huge problem in developing countries because you don't have a lot of those pollution control devices. So photochemical smogs as nitrogen oxides and VOCs, volatile organic compounds, under the influence of sunlight. Okay, it's a brownish orange haze. On hotter days, you have more smog. It peaks in the late morning and the afternoon, and then it starts to trail off after that. Okay, very, very particular types. Then you have ozone, O3. This is really good in the stratosphere. It blocks UV rays. Ozone depletion and global warming are not on the AP exam. That's Unit 9B that we were going to cover. We're not going to cover it before the exam. We're actually going to cover it after the exam. It's some really awesome stuff with some very relevant things going on right now in general. And so what we're going to do is after the AP exam, we're going to focus on that stuff. All right. Ozone is amazing in the stratosphere, but in the troposphere, it's very, very bad. It's a part of photochemical smog. So you have nitrogen oxides, VOCs, oxygen, and sunlight that creates this smog. Okay, it's ozone, okay, PANs and other oxidants. Okay, PAN is peroacetyl nitrate. Okay, ozone in the troposphere stresses plants. It causes respiratory illness, okay, asthma, bronchitis. It lowers visibility. My throat still is tight from whatchamacallit, from allergies. Okay. And then our ozone levels have actually been going down because we don't have as many hydrocarbons being burned right now. And the price of gas just went negative. I mean, a barrel of oil is now in the negatives. This has never happened before. So ozone, highly reactive. It's an irritating gas, an unpleasant odor that forms in the troposphere. And some copiers and printers used to emit ozone. It's a very kind of acrid smell. It forms from chemical reactions, VOCs from cars and industries, and then these nitrogen oxides, and that forms the photochemical smog. Breathing problems, coughing, eyes, nose, throat irritation. It can aggravate your chronic diseases like asthma and bronchitis, emphysema, heart disease. It can damage plants and trees, and that smog can reduce visibility. Um, it can damage rubbers, fabrics, and paints. All right, so there are a lot of changes in tropospheric ozone. It increases during the summers in the northern and southern hemispheres when the climate is hot. The most tropospheric ozone is observed during the summer in the northern hemisphere because the northern hemisphere, I don't know this, has the majority of the land and thus the majority of the people. So sunlight in cars gives you this photochemical smog. Most common in cities with sunny, warm, dry climates, LA, Athens, Rome. It's like I've done this stuff before. Mexico City is dry and sunny. They have a lot of cars on the road and they have a lot of photochemical smog. Right. Here's a fun infographic. You have nitrogen oxides. I'm going to draw on this. There we go. So you have nitrogen oxides over here from like factories. You have nitric oxides, nitrogen dioxides, and hydrocarbons. Then here you have oils from paints and gas stations and stuff like that. They form with your atmospheric oxygen. And then you have the UV rays that break the bonds, they recombine them, and then you get your photochemical smog. Okay. So this is photochemical smog. Okay. It can cause serious haze in a city. On the left-hand side, you can see smoggy. On the right-hand side, you can see clean. So outdoor air pollution can be reduced by a lot of different things. It can settle out. It can be when it rains, what happens is all of those water droplets literally attract the small particles in the air. Sea spray can also grab those particles and bring them down. Winds can blow them out, and then you can have different chemical reactions. In Beijing, I was in Beijing in 2007, the fall of 2007. It was before the Olympics, and the air pollution was just absolutely insane. And what they had done, there were dignitaries coming into the city or something. So what they did is overnight they throw, I think they're nitrous, some sort of chemical like bombs into the air. And what happens is they explode and they condense everything, and then it rains. And what that rain does is it grabs all of the pollution from in the atmosphere and it brings it down to the ground, which is a whole other issue. But what happens now is you have nice blue, clear skies after a rain. And now you just have all different sorts of pollution in your soil and running off into your water and stuff like that. We have more outdoor air pollution when we have urban buildings because that wind doesn't really disperse those pollutants. When you have mountains, those promote temperature inversions, which we're going to talk about. And then high temperatures are more sun and more photochemical reactions to make more photochemical smog and secondary pollutants. So, thermal or temperature inversion. I usually make you guys watch this absolutely terrible documentary. It's only about 25 minutes long. It's got to be from the 70s and it's like pixelated at this point in time. But they go over air pollution in a really great way. And it's like it's the worst, best thing. Students are like, I don't know whether I love that or I hated it. So thermal inversions are where, let's go with normal conditions. Okay. The sun comes down, it hits the earth warms up. Okay. And as you go up a mountain, it gets colder, right? So heat, it rises. And as it starts getting up, it cools off, right? So what happens here is that you get a layer of warm air that settles over a layer of cooler air near the ground. So basically, it should be warm down here and then cool up here. But what happens is they flip. So you get cool down here and then warm up here. The warm air holds down the cool air and it prevents pollutants from rising and then scattering into the atmosphere. It's kind of like throwing a blanket on yourself. It keeps that pollution in. So in these inversions, in sunny, light winds, mountains on three sides, sometimes an ocean on the other side, which gets a lot of big temperature differences. But this is what it looks like. So your normal pattern here is you have warm air, it rises up to cooler air and cooler air. Because of a warm inversion layer, the air gets trapped, you have this cool air. So this cool air, it goes up, it rises, it hits this warm layer, and it can't go up through it. Okay, so it ends up coming back down. So when you see smokestacks, oops, let's say here's a smokestack. What happens is, there we go, smoke rises up. No, it wasn't supposed to do that. It can't get through this layer. And what happens is then you see your smoke blowing in one direction. Like it'll go up a bit and then it almost makes like a 90-degree turn. It's hit that warm inversion layer. Right? These last for days, hours. It won't last for weeks and stuff like that. It's a weather pattern. As you guys know, the difference between weather and climate. Your weather is kind of this what's going on right now. Okay. Right now, I'm recording this. It is Tuesday. It is 6 o'clock. And we just had insane thunderstorms roll through. I was sitting in my driveway and it was hailing. There were tornado like winds in Tom's River. It was bad. That's weather. It came through. I'm looking outside now and it's sunny. Okay. So these inversion layers tend to happen for short periods of time. But when they do, all of that pollution gets trapped and that pollution becomes even worse. And you can have very dangerous air pollution levels for hours or in really bad conditions, days because of warm inversion layers. And that's Yay, answer the study guide questions. I hope everyone is good. I miss you guys. I will post more chicken videos. And I hope you guys are well. And I want to figure out some sort of an assignment so I can see what you guys are up to so we can share somehow. I don't know how I'm gonna make that work, but stay safe, cover your mouths. We're flattening the curve. New York is doing amazing things. Their death rates are coming down. New Jersey is stabilizing. We're behind New York a couple beats. But what's happened is that cases have moved from north to south. So you're starting to see our doubling times are now for New Jersey, except for one county, a week. Okay, so we're actually are slowing our growth, which is amazing. But we need to keep doing what it is that we are doing. All right. Miss your faces, and I'll see you guys soon.